Hello everyone, in this video we're going to discuss the tank mixture problem. Here's the situation. In a tank, there's initially a solution, and then there is an inflow solution at a constant rate Ri with constant concentration level Ci, and where stirred solution drains out and a constant rate Ro and with concentration level CO. Notice here CO is usually not a constant. It really depends on the amount of solute and the volume of the solution at the moment t. So CO is equal to Q over V. And our goal of this situation is to determine the amount of solute at any moment Q of t. So we need to create a differential equation for Q of t. We understand over a short time interval, amount of inflow solute is Ri times delta T times Ci, because Ri times delta T basically is the volume of inflow solution over that time interval times the concentration. So which is the same as Ri Ci times delta T. And also amount of outflow solute is Rho times delta T times CO, which is equal to Rho CO delta T, and certainly it's also Rho times Q of V times delta T. Now, the amount of change of the solute of that time interval delta Q is actually equal to the difference of amount of inflow solute and outflow solute. So it is equal to RiCi delta T minus RoCO delta T. We can divide delta T on both sides of this equation. We end up with delta Q over delta T equals RiCi minus RoCO. And we take the limit, and then we have desired differential equation dq dt equal to RiCi minus RoCO. And RoCO can be replaced by Q over V. So now we have a differential equation to solve for Q. And also certainly sometimes you will see prime notation for the rate of change amount of solute, Q prime equals RiCi minus Rho over V times Q. Now let's use this result to solve an example. A tank initially contains 1,000 gallons of water in which is dissolved 20 pounds of salt. A valve is opened and water containing 0.2 pounds per gallon of salt flows into the tank at a rate of 5 gallons per minute. The mixture in the tank is well stirred and drains at the same rate. Question part A, find Q of T. Part B, find the amount of salt after 200 minutes. Part C, find the limit of Qt as t approaches infinity. So there are a lot of numbers thrown in this example. Let's recognize which is which. First of all, you should know 1,000 gallon is the volume of the solution, and 20 pounds is the initial amount of the solute. So this gives us initial condition Q of 0 equals 20. And also 0.2 is the concentration of the inflow solution. So it is the value for Ci. And 5 gallons per minute is the value for Ri, because the tank drains at the same rate, so Ro is also equal to 5. So now we can plug in everything to the differential equation we come up with previously. So dq dt is equal to RiCi minus Ro times Q over V. So dq dt is equal to 5 times 0.2 minus 5 times Q over 1,000. And Q of 0 is equal to 20. That's our initial condition. So this is first order linear differential equation. We can solve it for Q. Now let's rewrite this as standard form of differential equation, first order linear differential equation, and prepare for the integrating factor method. So Q prime plus 1 over 200, Q equals 1. And integrating factor mu of t is equal to e to power little p of t dt, where little p of t is the coefficient of q in this equation. So it's the e to power antiderivative 1 over 200 dt, which is equal to e to power 1 over 200t. And then you multiply this integrating factor on both sides. The left-hand side will be the derivative product of integrating factor and the q. The other side is 1 times e to power 1 over 200t. So after you integrate this equation on both sides, the left-hand side goes back to e to power 1 over 100t times q. The other side, you have to do the antiderivative, and e to power 1 over 200t dt is equal to 200 times e to power 1 200t plus c. And then you can divide by e to power 1 over 200t to leave q by itself, and the q of t is equal to 200 plus c e to power negative 1 over 200t. Notice here is negative because c over e to power positive 1 over 200t. You change that to negative exponents by flipping that exponential term from denominator to the numerator. Now we can apply the initial condition q of 0 equals to 20. So 20 will be equal to 200 plus c times e to power negative 1 200 times 0. This implies c is equal to negative 120, and you plug that value up for the arbitrary constant c to the general solution. We got our initial particular solution. Q of t is equal to 200 minus 180 e to power negative 100 1 over 100t. So that answers our first part of the question. The second part of the question is found the amount of salt of 200 minutes. So now that we've already figured out Q of t, which is the amount of solute at the moment t, and in this case t is equal to 100. So all we need to do is just plug in 200 for the variable t and evaluate the expression. So you punch this expression to the calculator, and you found out it's 133.8. Part C, we want to investigate as time approaches infinity, what will be the amount of solute in the tank. So we're going to take the limit of this particular solution as t goes to infinity. And because e to power negative 1 over 200t is a decreasing function, exponential decay function, so we understand as t goes to infinity, the function value e to power negative 100t will decrease to 0. So the final answer will be 200 minus 0, which is equal to 200. It's understandable because if we want to make sense of this result, because the inflow solution is gonna keep flush out the tank mixture, and eventually the concentration of the mixture in the tank will be the same as the concentration level of the inflow solution, which is 0.2, and because the volume of the tank is 1,000 gallons, and 0.2 times 1,000 is equal to 100. That is the number we expect. All right, so this concludes the tank mixture problem. Hopefully this is helpful for you to complete the similar homework questions. Thank you for watching.